Good morning, this video will be focused on the development using a SciCompiler of a leading edge trigger connected to an oscilloscope. The leading edge trigger will trigger the acquisition of the waveform from the waveform digitizer inside the SciCompiler. Have a look to our setup. We have our Caen detector emulator that emulate a detector with an exponential output shape like this one, and this emulator is connected to our CDK board, that is the DT1260 board. The board is connected via USB to the computer, and the waveform digitized by the CDK board will be displayed on our screen using the Resource Explorer. We will also use the Resource Explorer to configure the trigger parameter. In order to create our project, we need to open SciCompiler, start a new project, select our target CDK, and enter the name of our design, that is ANSK008 underscore leading edge trigger. We have to place the analog input pin, analog 0, connect it to a trigger. Trigger is under toolbar, DAQ, trigger. We have leading edge and derivative trigger. For now, we will use a standard leading edge trigger. There are some configurable parameters. For example, the size of inward, the delay to be introduced on data, and the level of the noise filter. Noise filter is a moving average filter that is applied on only the data that is used for the trigger. This is useful if you have a noisy signal in order to reduce the noise. The trigger block, if we take a look, there are different input. The in is the analog input, and we can connect to our analog source. Then there is the threshold, the inhibit, and the polarity. Threshold is the threshold values in LSB and operate directly on the analog signal. The inhibit is the number of samples that is used to avoid that the trigger can fire choose consecutive pulses too early. This is useful if you have very slow signal, because in this way you can avoid that the trigger is fired on the falling edge if you have too much noise. So in the end, we have the polarity, that is for 0, the trigger looks for a positive signal, while if 1, the trigger looks for negative signals. Okay, so we can connect all these inputs to some registers. So we can create a read mode register. In particular, we can create threshold, create polarity, and create inhibit. Now we select threshold and set bit vector to 16. Then we place another register, bit vector 1 for polarity, and in the end we place a integer register for inhibition. Connect everything. And connect to the oscilloscope. So from the AQ we can pick oscilloscope. We can leave everything by default, so we have one track, 1024 samples, and digital inputs enabled. Just connect data, trigger, and TOT. But we want also to trigger the oscilloscope on the trigger output, so we can connect the trigger to start pin of the oscilloscope. Now we can memory map everything and start the compilation process by press compile. Okay, just wait 5 minutes for the full compilation. Okay, when Vivado finished to generate the firmware, we can proceed to download the firmware on the board. So we put the board in bootloader mode and we power cycle the board. Then we pass to generate, and then we program the flash on the device. Press boot to start the application. The LED now is fixed, is blinking. Open the Resource Explorer, select the board, CDK, connect, and we have the oscilloscope and the registers. So we can open the oscilloscope, configure in free running, and we can see that sometimes we have a pulse. We can increase the division to 150, so maybe we can see more time. Sometimes we have a pulse, but the trigger is not working. This is because we have not configured nothing on the trigger. Trigger is always high here. So we can go here and open this parameter. Polarity is not important for us because we have positive signal. So this is the threshold. Threshold that can be set, for example, at 2500. Okay, and now we can see that the signal is lower. Okay, at this point we can set the inhibit to, for example, 1000 in order to avoid the double pulses. Okay, we can now stop the oscilloscope and start to trigger on the on the external trigger. That means on the start signal. Okay. Sorry, this value should not be in hexadecimal, but in assigned int. So we can reset the values, and okay, you can see the signal, the oscilloscope that is triggering on the signal. But we have it, if, as I said before, you can have a double pulse, because after the 1000 samples, the oscilloscope can trigger again. Okay, and due to the noise, the trigger will trigger again on the falling edge. So we can increase this time. And now you can see that we have the trigger, the time over threshold, but no double trigger, because the trigger is inhibit for 2000 samples. If we decrease the threshold, we can see that the time over threshold becomes longer. We cannot see the end, so we have to reduce it, for example, 108. Okay, or move this one to 5%. Zoom out. Okay, now it's clear. We can see everything. We have again a double trigger, because now we have increased the length, so we are taking more signal. So this should be longer again, and now we have no more double trigger. Okay, that's all for this video. Thank you for your attention.